And good evening, AP Physics students. Mr. Kirsten coming at you here. Tonight we're going to take a look at problem number 9 in chapter 18. So let's dive right in here. In this problem, it says we have a high voltage power line, and we've got a bird sitting up there. Oh my gosh, what you doing, bird? And I was going to draw this bird before the video started, but then I thought that would deprive all of you of seeing in person how I come up with my awesome drawing skills, right? So there's my bird on a wire. Isn't that the best bird you've ever seen, right? It's going squawk. All right. So we've got a bird on a wire, and what is it doing? Well, this wire is carrying a current of 2,800 amps, lots of current, 2,800 coulombs per second flowing through there. And it says that the wire has a resistance of 2.5 times 10 to the minus fifth ohms per meter. So that's not the resistance, but it's the resistance per unit length. One thing I forgot to tell you is in the problem it states that the bird's legs are 4 centimeters apart. And then we want to know what is the voltage difference between the bird's 2 legs, right? Are we going to have a cooked bird here or what? Okay, so let's dive into this problem. Well, let's figure out what the resistance actually is between the bird's feet, all right? So we know that the resistance is 2.5 times 10 to the minus fifth ohms per 1 meter, and we know that the bird's feet are 0.04 meters, right, 4 centimeters apart, so we could figure out that the resistance between the bird's 2 feet is about 1 micro ohm, or about 1.0 times 10 to the minus 6th ohms, okay? All right, so that's the resistance between here and here. Well, how do I know what the voltage drop is across here? Well, let's talk voltage drops here for just a second. I think we all know that, let's say I have a 9-volt battery, right? And I put 3 equal resistors in series with this 9-volt battery. What would happen? Well, we're going to learn about next chapter that if you go around any closed loop, the voltages up have to match the voltages down. So in this situation, you'd go, oh, when the current goes through the battery, I go up 9 volts. That is, every 1 coulomb of charge that passes through the battery would gain 9 joules of energy, because a volt is a joule per coulomb. Well, if this is plus 9 volts, and these voltage drops across these resistors must be the same, then, you know, this must be minus 3 volts, minus 3 volts, minus 3 volts. Well, how would I come up with that if it wasn't something easy like that? Well, we know that by Ohm's law that current is voltage divided by resistance, so the current in a circuit is equal to the battery voltage divided by the total resistance. Well, what if I rearrange that and just say V equals IR? This will give me the voltage drop across a resistor. So if I know the resistance in ohms, right, and the current going through that resistor, I can use Ohm's law to figure out the drop in voltage across the resistor. And that's basically my plan for what I'm going to do with the bird and the feet, right? So I can figure out that the voltage drop between, or as the book states, the potential difference between the bird's 2 feet would be equal to the current flowing through the wire times the resistance, which we just figured out was 1 micro ohm. Therefore, the potential difference between the bird's 2 feet would be about 2.8 millivolts, or 2.8 times 10 to the minus 3rd volts. All right? Okay, good job, physics students, for your joke today. We got a treat for you, as always, for your reward. So some people think, Mr. Kirsten, you're so funny. Your jokes are so hilarious. Were you just naturally that funny? Well, no, I actually took a class in college called Laughing Lessons, and talks about how to use humor in the classroom, and it was a really cool class. And today I'm going to share a joke with you from that book. Great book. And the joke goes something like this. Hey, what do you do for a living? I'm a mathematics teacher. Oh yeah? Say something in mathematics. Pi r squared. Ha! You ain't so smart. Pies are not squared. Pies round. Cornbreads are square. There's your joke for the day. All right, nice work, physics students. This concludes chapter 18. We're going to be moving on to chapter 19 here. All right, good work.